Virtualization features, benefits, and trade-offs. As the title suggests, in this section, we are going to primarily discuss server virtualization features, the benefits, and the trade-offs of server virtualization. So the objectives are, of course, to discuss the 5 major features of server virtualization, and then the benefits of server virtualization, and of course the drawbacks of server virtualization. So what are the key features of virtualization? It's abstraction, partitioning, isolation, encapsulation, and interposition. Now these 5 features actually allow us to do a lot of things, and those are the benefits. But then there are some drawbacks, and that's what we'll discuss in the drawbacks section. Abstraction. The abstraction property of virtualization basically abstracts the VMs away from the hardware. And so the VMs, the virtual machines, are not really tied to any physical hardware. That allows us to easily move the operating system to another hardware. So all you have to do is take a snapshot of the VM, move it to any other machine you want to. Basically what that means is if you have to upgrade a machine or downgrade a machine or fix the hardware of the machine, you simply move the machine over and you can easily upgrade the hardware since it's not tied to the hardware. Partitioning. Partitioning allows us to run different operating systems on one physical machine, and the system resources can be divided between the VMs. Every virtual machine is getting its own snapshot of the CPU, the RAM, the network interface, the hard drive, or any of the other I/O devices. But everything is partitioned. Isolation. Every virtual machine is basically running in an isolated environment. The different operating systems are running, but they're all running in one physical machine in an isolated environment. The system resources can be divided between VMs, of course, although they are isolated. And when it comes to fault and security, that's also isolated. When one virtual machine fails, the other virtual machine is still operating. There's no problems there. What that means is that each VM can be managed separately. The patches, which could mean the OS patches or security fixes, can be done on one VM, whereas the other VM can still be running. Each VM has its own independent set of libraries, so if one VM is bringing in a certain library, the other VM doesn't have to get affected. The life cycle of every VM is completely different, so every VM starts, pauses, stops, and destroys separately. And like I said, there's fault isolation. If a VM crashes, the other VMs are still up and running. Encapsulation. Encapsulation is taking the complete status of a VM and persisting it. It can be persisted into a file if you want. What that means is you can take a VM, persist it into a file, because what you're doing is you're taking all its current state, registers, memory, processing, whatever it is, you save it into a file, and then you move it to a different machine, and then you bring it up somewhere else. You can basically launch a machine based upon those files. And this is possible because you are able to encapsulate the virtual machine into a serialized fashion. Interpositioning. This is an important aspect of virtualization. Interpositioning is basically injecting in between. In our case of virtualization, the hypervisor is actually injecting itself into everything. The hypervisor is basically sitting in between the hardware and the operating system. So the hypervisor is right here. What that means is that the hypervisor is watching the CPU, the RAM, the network card, the hard disk access, the I/O access, whatever it is, the hypervisor is monitoring. What that means is the hypervisor can do all kinds of things like monitoring, management, logging, security. All those things can be done by the hypervisor, and that's the interposition property or characteristics of virtualization. So those 5 characteristics that we discussed, those 5 properties that we discussed, leads to several benefits. And here I've listed all the benefits. What we'll do is go through each one of these benefits, and we can go through them pretty fast because I've kind of talked about these different benefits. Here I'm explicitly listing it out. Rapid provisioning. Well, in cloud computing, we always talk about we want to rapidly provision. Well, we can do that now. We have the ability to launch a machine on the fly now with virtualization. You no longer have to wait for provisioning machines. Well, we know that in the data center, the servers are brought in, they are networked, and they're ready to go. But then with virtualization, we can put in any operating system on top of that on the fly. That's rapid provisioning. Server consolidation. Server consolidation is consolidating multiple servers into a single machine. Well, in the olden days, we used to have file servers and print servers and email servers and database servers and web servers, and they would be all separate machines. Now we can consolidate all those machines into a single physical machine using virtualization, and that's what we call server consolidation. There is a term called consolidation ratio. You should be familiar with this term, consolidation ratio. Consolidation ratio is the measure of how servers are condensed due to virtualization. For example, you can say my consolidation ratio is 50 to 1. 50 virtual machines are being merged into one, or 32 to 1. So that's consolidation ratio. Efficient management of resources. Well, now because of virtualization, we can efficiently use the hardware. If you recall, because of Moore's law, most of the servers are actually underutilized. Now we don't have to worry about that. We can avoid situation where a server is underutilized or overutilized. Well, how do you do this? The idea here is that you use what you want when you need it. You create a resource, you consume it and collapse it, and now you're efficiently using the resources. And also, there are tools to automatically adjust resources. You can move virtual machines from one server to another server if one server is overutilized. And so you just simply take the virtual machine and move it over to a different machine. We'll talk more about this in one of the other benefits. Containment. The definition of containment is managing tremendous growth of something. In this case, it's managing tremendous growth of IT. On a daily basis, more and more organizations are automating their business processes, which means they need more servers. And then there are also new products and services that are coming on board. Well, that's generating a lot of demand on the IT resources, rather than having a single server for every one of those services. In fact, every service may have more than one server. What we can do is using features like server consolidation and other aspects of virtualization, we are actually doing containment. In a way, virtualization is offering containment for us. Snapshots and rollback. With virtualization, now you can take a snapshot of a VM. Remember, snapshots are a complete copy of the CPU registers, RAM, and hard disks, and store it in some kind of a flat file. You can store it and then you can restore it on a different machine. Snapshots can also be used to do a rollback. You may want to take a snapshot of a VM and then you can roll back that particular VM later on. It's important to remember that when you do snapshots of VM, it's not the same thing as doing a backup. Because every time you take a snapshot of a VM, it is going to be the sum of all the hard drives that you have. And so what it means is, if you take a virtual machine and then you take 5 snapshots of that virtual machine, that means you're actually using 6 times the space. There is the original virtual machine, and then there are 5 other copies. Versus backups are things where you can have deltas. They're incremental backups. So don't think that snapshots are the same thing as backups. Snapshots are not a replacement for backups. They just allow you to take a snapshot of a VM and move it somewhere else. You don't want to use it as a replacement for backups. Load management. Well, when a VM gets busy running on a host machine, and it may be because the VM is busy, or it may be that the host machine is busy because there is some other VM that's busy. In such cases, what you can do is you can actually move the VM over. You can copy the VM over to the other host. And this is possible because of interpositioning. The VMs can be on the fly moved, and we'll show you an example of that. Scalability and grow on demand. Because you can launch VMs on the fly, you can now grow your services on demand. You can bring in VMs only when you need them. You can increase the CPU, you can increase the RAM, you can increase the hard drive on demand, or you can even bring in more copies of that particular VM on demand. So scalability is a very important aspect of virtualization. And there are also automated tools that automatically adjust resources. If a virtual machine is short of resources, there are tools that will add resources to it. If a virtual machine is using excessive resources, There are tools to adjust to bring it to proper level by moving that virtual machine to a different location. There's a lot of things that you can do. You can even forcibly control that particular virtual machine to say, don't use that many resources or cut down the resources. There's a lot of things that you can do here. High availability. You can do automatic movement of VMs when there is failure. There is no need for dedicated standby hardware. In the olden days, we used to have a primary machine and a standby machine. We don't need to do that. We don't have to incur the cost and complexity of clustering now. So let me show you an example. We got 3 machines over here, machine 1, machine 2, and machine 3, 3 physical servers, and they have virtual machines running on them. We have a green VM, we have a gray VM, and an orange VM running over here. Okay, so let's say that this particular server crashed. That's the big X. You'll notice that the 3 virtual machines got moved to 2 other servers. So you can see here's the red one, here's the green one, and here's the gray or the blue one. So that's an example of high availability. When a server crashes, you can move it to a different machine. And of course, this requires that you have a snapshot of that particular VM. You can also achieve zero downtime maintenance. You can evacuate hosts, move running applications to other servers without disruption. You can perform maintenance at any time of the day. And there is also zero downtime for hardware maintenance. So once again, we have 3 servers and they're all running their VMs. And you want to do maintenance on this particular server, the one that's orange right here. We want to do maintenance on this orange server. So you activate maintenance mode on that server. You then move the virtual machines to other hosts. You shut down the idle hosts and perform maintenance. And then you restart and you bring it back. I'm using this term called DRS. It's actually an attribute of VMware. It's actually a feature of VMware, which allows you to do this kind of load management, do migration and maintenance of hardware. Many different virtualization software allows you to do this. Let's talk about disaster recovery. You can save the state of a VM at any point in time. Like we said, it's called snapshots or checkpoints. What that means is when a hardware crashes or when there is a problem with the data center, it's not a problem. We have a snapshot of that particular VM in a different location. All we have to do is launch the VM in a different location. So we have disaster recovery built in because we're able to take a VM, save the state of it, and bring it up somewhere else. We can use snapshots to recover from unplanned disaster. Now, depending upon when you took the snapshot, you may have lost some data, but at least it's possible now. Reduce energy costs. Because you're doing virtualization, many of the servers don't physically have to be up and running. You can move many of the VMs into a single machine or a few machines. Let's say you have 500 machines in your data center. You can have only 100 machines that are actually running. You don't really have to have all the 500 machines powered on. So because of server consolidation and also dynamic management of computer resources, which means you can move virtual machines from one machine to the other, you can actually reduce energy costs within your data center. And you're doing this because you're powering down servers without affecting applications or users. That leads to a greener technology, less power and electricity needed for servers, and less power and electricity needed for cooling. There is also this concept called DevOps and automation. We'll talk more about this in a different module. Hypervisors typically expose API calls. There are APIs available that allow you to launch machines, shut down machines, pause machines, restart machines. What that means is you can now write software, build it, deploy it, and when you deploy it, you can automatically deploy it into a machine by launching a machine, test it, and then bring it down. So you can do all those things. Build, code, plan, deploy, all those things can be done. In fact, even the release management can be completely different. You, rather than giving software, your RPM packages or your zip files to the operations team, you can actually build a VM, take a snapshot of the VM, or that's the VM that you'll release, and that will come on to production. So the idea of DevOps and the idea of automation really has taken off because of virtualization. Like I said, you can now have virtualized test environment. You can have temporary test environment. In many organizations, they would have production environment and they would have a complete replication of it as a test environment. No, you don't have to do that. Only when you're testing it do you really need the test environment. You don't really need the test environment all the time. That's the idea of DevOps model. You build your application, you launch test environment, you do automated testing, and then you shut down. So you can have a temporary test environment. You can have a variety of test environments. For example, you may want to test your software in different operating systems, and you can do that by launching different VMs. You can even test your software on different kinds of hardware specification, more CPU, more RAM, multi-core, all kinds of things can be tested now. You can also use snapshots and checkpoints to create test environment from production. So if you want to get a copy of what production looks like right now, you can do that. You can also scale hardware. Like I said, you can launch VMs that are 8 gigs of RAM and 30 gigs of storage and 4 core, and you want to see how that software is going to work if you go to 16 gigs of RAM and 16 core and 100 gigs of hard drive because you want to have more cache space or something. So you can do all those different kinds of testing by launching virtual machines with different kinds of hardware capabilities. Well, you can also launch multiple copies of the same hardware and test out your system. Security. The isolation attribute of VMs helps in security. It's possible to run VM in its own container, and so you're locking it down. If one VM is affected, the other VM is not really affected. The snapshots also help in security. If a virtual machine is compromised, then you can go to the snapshot and retrieve from the snapshot before the attack. The workload management, when one VM is compromised, move that VM to a separate host or move all other VMs to another host. In this way, you're basically isolating that particular VM which has been infected. So it also helps in security. So virtualization also helps in security. Let's look at the trade-offs of virtualization. Every technology has advantage and disadvantages. Now let's look at all the trade-offs. Here are the different trade-offs. Let's look at them one by one. Multiple VM failures. Basically what I'm saying is if a single machine crashes, then all the VMs on that particular machine are also going to go down. Unless you have features like vMotion that allow you to move the VM on the fly, which is your disaster recovery software that many of these third-party virtualization software vendors offer, you are kind of screwed. Basically, when a server goes down, you lose all the VMs. Performance degradation. It's possible that one of the VM is getting really busy, and so it may affect other VMs until you actually move it over. So there's that you need to worry about. You'll notice that even though there are trade-offs, you can always offset these trade-offs. Increased complexity. There is complexity in management. In terms of the hardware, in the olden days you had hardware and then you had operating systems installed and then you had programs installed in it. And you would label each one of the hardware. Everything was tied to the hardware. Now you have virtual machines. These virtual machines could be running anywhere in any of these hardware machines. So you want to kind of keep track of where these virtual machines are running in terms of management within the data center. So that adds complexity. Good thing is that many of the virtualization software vendors do give you some kind of a management software. In fact, that's what they charge you for. There's also complexity in networking. Hypervisors are basically working with the NIC card, virtualizing the I/O devices for the network interface card. And because of the virtual switch concept, there is complexity that is associated with that. Well, there's also increased network load. Increased network workload is because you have your physical hardware, you have your physical network, and then you launch virtual machines. And as you start launching virtual machines, you're not really going back and really reevaluating your physical hardware network until at some point when things start becoming slow. Well, people are launching a lot of virtual machines, and virtual machines are going to start using a lot of bandwidth, and at some point you may actually run out of bandwidth within these different virtual machines. So you have to be a little bit careful. You have to keep track of how the network utilization is happening within, because now you have more virtual machines running within a few set of physical servers. So you have to be careful about that. You have to just kind of keep an eye on those things. There's also misconfiguration, which could lead to slow networks. For example, when you take a VM and when you clone that particular VM, you may inadvertently have duplicate IP addresses and MAC addresses in the other VM. So when you clone a VM, the other VM has exactly the same IP address and exactly the same address. Before you launch that cloned VM somewhere else, you need to make sure that you actually change these IP addresses and MAC addresses. If you don't, then you have two machines or two virtual machines in the network with the same IP address and with the same MAC address, and the network can get confused, and so that could lead to slow networks. The point I'm trying to make is when you do virtualization, you got to do it right, and if you make mistakes, it could lead into some slow network issues, but problems can be fixed. It's not a big deal. All these things can be, once identified, can be fixed, but for some slight duration, you may notice some slow networking. Expense. To take full advantage of virtualization features, commercial support may have to be bought because many of the virtualization software come with some kind of a management software, and that's where they charge money. So you have to pay license fee for the virtualization software. It's definitely worth it if you want to do virtualization in the best possible way, but then it comes with a price. Proliferation or sprawl. It is very easy to create a new VM, and so that leads to wastage. In many organizations, too many virtual machines get created. In the olden days, if you wanted to get a server, you have to go through all kinds of procurement process, and everything was tracked. Now you have a console in your cloud environment. You just have to go in and then say, I want a machine with 8 gigs of RAM, 16 core, 30 gig hard drive, and you get a VM. And you will see that there's a whole bunch of VMs that have been created, and so that leads to wastage. That's what we call the proliferation or sprawling of VMs. And so you want to kind of manage that. That's one of the disadvantages of virtualization. So what are the tips? Well, you want to change human behavior, remind people that VMs take resources. They take CPU, they take memory, they take power, they take storage. You want to remind them about that. Decommission unused VMs. Constantly watch any VMs that are not being utilized and terminate them. Identify temporary VMs. When you launch a VM, you may want to label that particular VM as temporary. So after some time, you can delete that particular VM. And you can see this when you actually start working with Amazon Web Services. You can actually have a label associated with a VM. And that will allow you to set a key value property. And in the key value property, you can say it's a temporary VM. Audit VMs. Do periodic auditing of VMs associated with dev, QA, and production. If you don't need it, turn them off. So you got to constantly audit your VM. Now let's talk about security issues. Virtualization does lead to some security issues because of proliferation, which is basically very easy to create your VMs. Developers start creating VMs. QA professionals start creating VMs. And they create these VMs without much security in mind. In fact, they may keep all the different ports open when they should have shut down many of the ports, and they may not have installed the latest patches. So all these things could lead to security issues because now hackers can easily get into your virtual machine. There is also sharing multi-tenancy, which causes security concerns. What I mean by this is if one malware infected VM is there, then it could affect another VM in the same host. And one malware infected VM could also affect the hypervisor, which is a worse condition because now it could affect all other VMs, and also could affect the network because virtualization is communicating with the network devices, and so it could affect other things, network, storage, and all those things, and all those other IT resources. Every VM should have anti-malware software. That's one of the things that you should really do whenever you install VMs. Portability also leads to data computer theft. Remember, I said to you that virtual machines are portable. What that means is you can take a VM, take a snapshot of that particular VM, and then move it somewhere else. Well, if you can take a snapshot of the VM, well, a hacker can take a snapshot of the VM and then just copy the file over and then run it somewhere else. And these VMs may have very valuable data in it. It may have customer data in it. It may have other kinds of proprietary software in it. The hacker can now run any of these things. It's almost like stealing a computer. So you have to be careful about VM theft. In summary, the key features of virtualization are abstraction, partitioning, isolation, interpositioning, and encapsulation. These key features lead to several benefits. It allows you to rapidly provision servers, allows you to consolidate servers. You can now efficiently manage the resources. Containment, which is basically managing the growth of servers within data center. You can do snapshots and rollback, load management, scalability on demand, zero downtime, because now you can actually move VMs when you're doing maintenance, disaster recovery, reduce energy costs, green technology, automation, virtualized test environment, and security. So there's a lot of advantages that we have because of virtualization. In terms of trade-offs, well, there's multiple VM failures. If one VM fails, all the other VMs would crash within that machine unless you have some kind of a DRS software built in. There's also performance degradation. One VM can bring down the performance of the other VM. There's also increased complexity within the data center, increased network load. There were a couple of situations that we talked about. Expense, because now you have to pay for virtualization license. And then there's also proliferation or sprawl, too many VMs created. We also looked at some of the new security issues related to virtualization.